Hello. Sorry, I looked up at the screen and I saw your questions. I was like, oh, okay. I need to open my copy of the lab. So I think that is the thickness question. Yeah. Okay. So I know that we went over how to do the calculation on the lab video, so you can definitely check that for this. But the gist of it is that the density of that's not the drawing tool. There we go. So let's see here. So the density of anything is equal to the mass of it divided by volume. And we know that for an aluminum sheet, the volume of such a sheet would be the length times its width times its thickness. So what that means is you can then substitute this into this expression here. And then to solve for the thickness, you just solve for T here. And then when you put in all the numbers in their units, so this should be in grams. Density is in grams per cubic centimeter for a solid. And each of these is centimeters. Which means that this will be centimeters too. And so there you go. So now that you know what the formula is, you can then plug in numbers, and the numbers should be shown in the lab. I don't want to do any more than that, just because then I'm basically doing the problem for you. But that should be what you need set up. Danny, I need more information for that problem because I only have... I need conversions that are given in that problem. If you know what quiz it is, I can look up some random numbers. There you go. Okay, I can work with that. The exam is units 1 through 8. So unit 8, which is tomorrow's lecture, is also on there. That's the wrong color. So I need cubic squips, and I know that a squip... Well, let's start here. So I need to turn gallons into cubic squips. So in order to do that, and I know there's a relationship between squips and centimeters. So since I know this relationship, then I could get cubic squips by just cubing everything. And I need my calculator for that. So what's 14.4 cubed? 90. I don't actually need this parenthesis. There you go. Okay, so now I know that. If I could get something into cubic centimeters, I'd be all set. Well, cubic centimeters are the same thing as milliliters, right? So if I get gallons to milliliters, I'm all set here. I know gallons to liters exist, so we'll just do this. So, gotta look up the conversion between gallons and liters, and that's on Google. So you can do that on Google. 1 gallon to liters, 3.785. So let's write that down here. Liters to milliliters, so there are 10 to the minus 3 liters per milliliter. These are equivalent, just 1 to 1. And then this conversion from cubic centimeters to cubic squips is what we determined down here. So now we can just do the calculation. I'm going to move this number over because I'm going to need more space. So now I can turn, according to my chart, I'm going to go gallons to liters to milliliters to cubic centimeters to cubic squips. So let's do that. So gallons to liters, liters to milliliters, milliliters to cubic centimeters, and then I ran out of space, so cubic centimeters to cubic squips. All right, now that I have the units that I want, let's do the numbers. So 1 gallon is 3.785 liters because we wrote it down. A milliliter is 10 to the minus 3 liters. That's that right there. This is the same thing. And then here's our number down here. So one of these is 2,990 of those. So punch it on the calculator. Assuming you hit the right buttons, that's important. Make sure not to make a mistake. And I got 287 cubic squips is what my calculator says. And that's after we've counted for sig figs, because this had 4, this had 4, but this one right here only has 3. And it has 3 because this has 3. There you go. So yeah, again, exam number 1 is units 1 through 8. Unit 8's real short. It's just periodic table. And the exam is on Monday. Yeah, they aren't easy. So my strategy would be to do this every time. Oops. Not to do that. Draw a red line over everything. My strategy would be to do this part every time. Set up your blueprint. Don't just try and go at it and throw units around. Set up the blueprint. Establish a way to get to your goal. And then do the calculation. Eventually you will get to the point after you've done like thousands of these that you don't need to do the blueprints anymore. And it's just a matter of practice. Maybe not thousands, I'm being a little hyperbolic there. But you do have to do a lot of them. And as you get better at them, you'll start to see the connections. Other questions, let me know. Can I go over how to make a graph for the lab? I've already done that in the lab documentation video. So if you need to check how to make a graph, check that video for the lab from week... What week would it be? 4? Yeah, week 4. When we made a graph. Yeah, if you have a Discord question, I can answer it here. There's a very loud dog outside that I hope the mic isn't picking up. He is very happy to see somebody. Whoops, my window got hidden and I missed the question. All right, so let's see here. Oh, I wasn't even at the top of the screen. Boop. There we go. All right, so why do you have to convert it to 5.54? So you have the right answer, right? 5.536 whatever. But you need to have the correct number, sig figs, which would be 3 sig figs. So you have to round it to 5.54. All right, so I want to find. Oops, I gotta get rid of these little dashed lines here. A distance equal to this. Okay, so I have to turn this distance, which I can then turn into kilometers, and I need to turn that into, eventually, miles. So I know that there are, in one band, 3.02 kilometers. And there is a conversion between miles and kilometers that exists. And I think it's this. But last time I did a problem on here, I typed in the wrong number. So I'm going to look it up. 1.609 kilometers. Okay. Why wouldn't it be 5.53? Because 5.53, the next digit is 6, and that's 5 or greater, so you round up to 5.54. So band to kilometer to mile. So one of these is 3.02 of those. That's what we got right there. And in a mile, there are 1.609 kilometers. So we punch it in the calculator, and what do we get? 2.95, 3.02, 1.609. I got 5.53697, which is the number you have on your screen. But I got to round it to 3 sig figs. So I need to write 5.5. So this is what I get, but I only get to keep these 3 sig figs. I'm going to round it to 5.54. Maya says hello. Hi, Maya. Yes. Maya is once again here. I was literally petting her for 10 minutes while everybody was asking questions and the music was playing. She leaves happily content, and now she's back and wants more pets because cats. That was interesting. I didn't realize that I could grayscale my. How the heck did I do that? I hate that I can't undo on Photoshop. Somehow I have removed all color from the world. And I don't know how I did that. Was it because I did this? This? Oh my goodness, Photoshop. Well, the solution to most problems is whenever something breaks, close it and open it, right? There we go. Great. I do not need that students problem on there. I don't know why that's... That was a question a student asked me between class periods. So whoever's posting in the Discord, I can... So it's a question about sig figs and percent error. So I can just make up some numbers here. So let's suppose that you do an experiment and your result that you get for the experiment was 8.84 grams per cubic centimeter or something. And the literature value would be 8. Let's say 5925. All right, so percent error is experimental minus true over true times 100%. Now, I know some people see the formula that has absolute value bars. Don't use absolute value bars. Get rid of them. The reason being is that if you get a negative number for percent error, that just means your answer is less than the true value. Our result is going to be a positive number because I have a larger number than the true value. But if I instead had this, now I just have a negative number. Negative does not imply bad. Think of it as a number line. And so if your answer is right here, this is the true value. Then a percent error of positive 3.6 would be an answer that's too big, whereas a percent error of negative 0.8 would be slightly too small. So let's plug in our numbers and see what happens, and then we'll do all the calculations with it. So 8.84 grams per cubic centimeter minus 8.5925 grams per cubic centimeter divided by 8.5925 grams per cubic centimeter. All right. Whenever you do any problem in this class, I don't care what the problem is with math. If math is involved, use sig figs, okay? So never ever ask the question, should I apply sig figs? Because the answer is always yes. So what that means is we're going to do the subtraction. 8.84 minus 8.5925. And you can see that if I try and round to this position, there's nothing here or nothing here. So this is the first position I'm going to be able to keep. So let's do the subtraction. That's not how you do subtraction. Uh, 4, 2, 0. And again, I'm not going to keep these digits because of these question marks here. So the result that I get on the top here is 0.24. So let's go to the next step. I forgot my 100% up here. This is all multiplication and division, so I'm going to just punch it in the calculator and get an answer. So 0.24 divided by 8.5925 times 100%, and I get 2.7931 percent error. But because of the subtraction right here, I only have 2 sig figs. So that means that when I do all this division, my answer should have 2 sig figs. And so this is what I would report for this specific problem. Anytime you do percent error, you're going to follow the exact same procedure. If your answer is very close to the true answer, you could end up with only one significant figure in your error. And that's because as your error gets smaller and smaller and smaller, it gets harder to define. If you have 0.05% error, your error is really tiny, and it's hard to measure something really tiny. If you are having trouble with sig figs, then I strongly recommend that you go and review Unit 2. Make sure you're doing the worksheet. Do those problems again and check your answers against the worksheet. That's really the best advice that I can give. Yeah. Yeah, the experimental minus true is the important part of that setup. Because that is the first part, and that's going to change the number of sig figs. So follow the sig figs rules. How much food will the cat eat in this amount of time? So let me see here. There it is. All right, so we know how much food the cat eats each day. And I want to see how much food the cat will eat in this period of time. So I could turn some number of years into a number of days, and eventually I need to figure out how many pounds of food are going to get eaten. So I know how much food is eaten in grams per day. So if I turn this into days, then I can turn this into grams. Because this conversion right here says that one day is 58.2 grams worth of food. And if you look up a conversion for grams to pounds, you could find that. So there are 453.6 grams in a pound. That's on Google. And then we have the time conversion. That many days in a year. So I could set up the dimensional analysis. We're going to turn years into days. Years into days. And then we'll turn days into grams. Because I want to figure out how much food they're eating in this many days. And I can turn grams into pounds. And I just fill in the numbers. So there are 365.25 days in a year. The cat eats 58.2 grams per day. And 453.6 grams in 1 pound. Punch it all in the calculator. And I get, looks like this will all be 3 sig figs because I started with, this has 3 sig figs over here. This is 5, 3, and 4. So the lowest is 3, so I'm going to report 61.86059. I'm just going to round that to 61.9. There you go. All right. Doesn't look like there's anything else. And yep, that looks good. So we're gonna take a break. I think I'm gonna put the break time message up. I'm gonna let this sit here and collect more questions. So we'll start this, and I'll come back and check on it, and I'll answer any questions that you might have when we return. So we'll see you in a bit. Alright, so let me hit this. So, classify a chemical... Oops, I didn't hit the button here. Classify a chemical versus a physical change. Alcohol evaporates, sugar dissolves in water, paper towel absorbs water. So, for each of those things, you need to tell me, does the substance change its chemical formula or not? And so, for the first one, for alcohol evaporating, that tells me that you're turning something from a liquid into a gas. And so that's a phase change. And phase changes are always physical. Sugar dissolving in water. So if I do this, I put it into a container. So my sugar will dissolve into the container. But does a chemical reaction occur? Well, the only really way to know if that happens is to remove the water, and that would be by boiling it off. And when that happens, you get sugar back. The water has been boiled away. So this is just mixing, which is also physical. Whenever you mix two things together, if you don't see something really obvious happening, you're doing a physical process. So, for example, if you mix Alka-Seltzer with water, what ends up happening is the Alka-Seltzer starts bubbling and fizzing and hissing, and that would be a chemical reaction. But when you put sugar in water, it just dissolves. It goes away. So all you're doing is mixing it. And then the last one, paper towel absorbs water. The water is just stuck to the paper towel. You could remove the water by squeezing the paper towel, and that would wring out the water and it would separate. So that must be a physical process too. If you let the water evaporate, it's also a physical process. It's still water and you still have the paper towel, and you could use the paper towel again. Although, why would you? It's paper towel, right? All right. That was the only question that I got during the break, so I'm going to assume that there aren't any other questions, because otherwise you would have typed them in. So I'm going to call it a day there. And I'll still be around for the rest of the afternoon and evening. I just need to take care of a few things around the apartment before I do my evening lecture. So thanks for coming out to the review. If you have any other questions, please let me know over Discord or by sending me an email. You can always like photograph problems and send them to me there too. Thanks for watching, and we will catch you tomorrow for the lecture on Chapter 8. So see you for that.